Welcome back, everyone. Mr. Tanner here. And for these notes, we're going to once again be looking at uh, another element and how it cycles through ecosystems. Last time we looked at carbon. Today we're going to be looking at nitrogen. And these are both organic elements, which means they're really important for living things. So the nitrogen cycle is going to look a little bit more complex than the carbon cycle did, but we're going to simplify it. So the purpose of these notes is to simplify the diagram and then really show you what you need to focus in on for your understanding, because this is pretty in depth, but we're going to not explore every single aspect of the nitrogen cycle, but just kind of combine a few things to make it a little bit more straightforward for you. So here we go. So here is the diagram of the nitrogen cycle, and this is the diagram that you should have taped into your notebook right now. And just like we did for the carbon cycle, we're going to start with atmospheric nitrogen. So nitrogen that's in its gas form in the air. And in this case, it's just N2. What's really interesting, at least I think so, is that almost 80% of our air is nitrogen gas, just N2. But it's so non-reactive as a molecule that most life can't do anything with it. So we breathe in 79% of nitrogen, and then we just breathe it right back out. It doesn't go into our body. It doesn't react with our body. It does nothing. It just goes in and out and doesn't change. But living things need nitrogen, so we have to take that nitrogen and turn it into a usable form for living things. And that's really the umbrella that we're going to use for nitrogen fixation. So you'll see nitrogen fixing bacteria here. These ones literally live on the plants. So legumes like peanuts, right? They have these nitrogen fixing bacteria that live inside nodules in their roots so that they can always tend to get usable forms of nitrogen. There's other bacteria that just live in the soil that do nitrogen fixation. But then what you're also going to see is ammonification, nitrification, nitrifying bacteria. And instead of focusing on all of that and focusing on ammonium and nitrites and ammonia and all these different forms that nitrogen can take, we're going to just put nitrogen fixation into an umbrella term. So we're just going to say, in general, nitrogen fixation is the process of turning atmospheric nitrogen into a form usable for life. So then these forms could be ammonia, ammonium, they could be nitrates, but we're not going to worry about that level of detail. Just in general, nitrogen fixation is the process of turning atmospheric nitrogen into a form usable for life. And what is necessary to know is that bacteria does this, but so does lightning. When lightning strikes the ground, some of that nitrogen gas that's dissolved into the ground gets turned into usable forms as well. So lightning strikes actually play a role in this as well. Let's go back up to the diagram. Once we have the nitrogen in these usable forms, that ammonium in the nitrates or nitrites, either one, plants can then take it in through their roots. So plants take in that nitrogen through a process called assimilation. So that's going to be our next term here. So assimilation is plants taking in the usable forms of nitrogen compounds. And unlike carbon, which is just taken in through their leaves, they take carbon dioxide directly from the air into their leaves. Nitrogen, they take in through their roots. You don't need to write that down, but it is worth knowing that they get the nitrogen from the soil through their roots. If we didn't have a way of getting this any nitrogen compound, whether it's nitrites, nitrates, right, nitrites, nitrates, ammonium, if we couldn't get that back into the atmosphere, then what we should see is our atmospheric nitrogen levels drop over time, but they don't. They stay very, very consistent, and that's because of things like denitrifying bacteria that can take these compounds of nitrogen and just turn it back into atmospheric gas. And in general, whatever process leads to that, usually bacteria, we're just going to call it denitrification. And we will just say it is the returning of into that the atmospheric nitrogen to the atmosphere. So we get that nitrogen gas back into the atmosphere. And then the last two terms you should be very familiar with from the carbon cycle. Consumption. The process by which organisms gain their nitrogen through eating. So animals like you and me have to eat food to get the nitrogen that we need. And then decomposition is the breaking down of living things to release stored matter. And in this case, we're specifically focusing on nitrogen. So let's look at that diagram one more time to try and just break down what we're looking at. So we start with atmospheric nitrogen, either through lightning strikes or nitrogen-fixing bacteria that can be on plants or in the soil. We take this nitrogen gas and we turn it into one of the usable forms of nitrogen for plants. So nitrogen fixation, we get usable forms of nitrogen compounds for plants. Plants then assimilate, they bring in that nitrogen into their roots so that they have the nitrogen they need. Animals consume the plants to get the nitrogen that they need. This is consumption here. And then some of that nitrogen in the soil in those usable forms is turned back into nitrogen gas and brought back into the atmosphere through these denitrifying bacteria. That's denitrification. And then finally, when any living things dies, decomposers release their nitrogen back into the soil. And this cycle goes on and on. So I know this diagram looks like a lot, but hopefully this video will help you simplify it in a way that's easy to understand. Thanks for watching. Let me know if you have any questions.